Hi, seventh grade. Today you are going to have a lesson on weather fronts. This is a continuation of the lesson that we had yesterday where we had the warm and cool masses. We used water and we put them together and they reacted differently to each other. So this is activity 4.2b. Today is May 3rd. Oh, wow. Back up. Today is Thursday, May 7th. Wow, I'm going back in time. All right, your agenda today, you have your bell work, this video lesson, and then you have some entries to put into your interactive notebook. Nothing major, a lot of copying and pasting. And then you need to do your, fill out your barometer entry for today. Okay, your daily work is the same things, your bell work, your entries, and your barometer reading. By the end of this lesson, you will know what a weather front is and how it changes with the weather. And you're going to have some updated vocabulary words because that's part of what we're doing. Reminders, assignments, when you turn in your assignments that are late or you want to redo a score, you need to come up here to the top of the classwork page and let me know in this format what it is you are doing. So your name, the date of the assignment, and the title of the assignment. Unless it's in here, I will not be able to find it. Please don't leave me a message on one of the assignment pieces because I would have to go in and check each one of these multiple times a day to be able to make this work. And I'm sorry, that's just not feasible. If you can't get a hold of me on here, or if I'm just not answering, or there's some kind of a breakdown in the communication, come to a Zoom meeting, interrupt me if we're playing a game and say, I have a question. I'm happy to help. I'm here for you. Or you can send me a regular email. Okay. All right. So that's that for that lesson, or that part of the lesson. All right, so we have some terms. Now, as we go through these, we're going to expand on these more. You might not quite understand what these are yet. Don't worry about it. We can always come back to it, and we'll be coming back to it throughout the lesson. Okay, so high and low pressure. We studied this last time. High pressure is when the cooler air is sinking. It is more dense, and this results in a higher pressure on us. So when we talk about air pressure, we're talking about atmospheric pressure. All of the air molecules in the air are pushing down on us. It's trapped by gravity, and it's pushing down on us. And in some places where it's cooler air, it's pushing down farther because that air is more dense. A low pressure area is where the warmer air is rising. It's less dense. Okay, this results in a low pressure because it's moving up, it's more buoyant, it's just not quite as many molecules. The result is very minimal. Most of us don't ever sense it. Sometimes you can get a headache from it, but that's about it. We're not going to notice these things. Okay, the front. A front in weather is the boundary between the less dense and the more dense air masses, so the hot and the cold areas. Instability, Mrs. Porter. No, just kidding. Instability is when air is unstable, when two masses do not mix quickly, and the warmer air continues to rise within the cooler air around it. So we're getting a lot of movement. That's going to result in a lot of different weather systems happening. Lift. We know what lift means. It means to rise. So lift is when the cooler, denser air mass moves under the warmer, less dense air mass. Okay, and pushes it up. It's lifting it up. We're going to watch a video that's going to have some demonstrations of that. All right, so quick revisit. Yesterday, we looked at what happens when we have two air masses that meet and how the air masses mix together. And we showed this demonstration with some hot water and some cold water. And we put the two glasses together and we showed what happened when the two of them mixed. Okay, so let's quick review. When we had the warm water on the bottom and the cool water on the top, okay, the warm water is more buoyant than the cool water. So it pushed up here. And as a result, it pushed the cool water down. And that makes a convection current. Okay, and it quickly turned our whole bunch of our red and blue water into purple water. It's a really nice, easy way to see the demonstration. Okay, now when we put the warm water on the top and the cool water on the bottom, they didn't mix hardly at all. There's a little teeny bit of purple here, but for the most part, it stayed apart. Okay, now the reason why it did that is because the warmer water, of course, has more buoyancy. It's going to float over the cool water, which is more dense. So that's why it didn't mix in. This was lighter, the red was lighter than the blue. So it stayed on the top. It's not going to mix. Okay. Now, if we had mixed it, with the straw or something, then it would mix. But if we just left it there, it wouldn't. Okay, this is a new word, equilibrium. Equilibrium comes from the word equal, so we know it's the same. When two air masses blend together, this is called equilibrium. Equilibrium in the air can happen quickly or slowly. When equilibrium is reached quickly, scientists call this a stable atmosphere. Okay, now this can happen in a couple different ways. I can have a cool front and a warm front, and they mix together and make our regular here purple front. We have equilibrium. But what if I took a warm front and a slightly less warm front? Okay, because they're almost the same temperature, they're going to have equilibrium quickly. Same thing with cool and cooler. Okay, they're just slightly different shades to represent the different temperatures. So if I have this warm on top, cool on the bottom, warm and warm, cool and cool, I'm always going to get a quick equilibrium. Okay, and this will be a stable atmosphere. Now, remember we talked about unstable or instability? That comes when it doesn't mix quickly. So just like here, we had the warm water on the top and the cool water on the bottom. If I have this, it's not going to mix, and that can cause a problem. Now, the boundary between the two masses is called a front. Fronts can react to each other in different ways. Okay, so we've got a little video. And the narrator is a little dry, but the animation is what we're looking at.
This animation is going to describe how precipitation happens at what are called cold fronts and warm fronts. These are weather systems that develop wherever masses of cold air collide with masses of warm air. And the name actually comes from war, where armies would meet along a battle line called a front. And one way to think about the difference between cold fronts and warm fronts is to think about which mass of air is going to win the battle. So we'll start with a cold front. This is a situation that happens where cold air moves in like a big wedge underneath warm air. Cold air is always heavier than warm air, and so it's denser, and it's going to tend to slide under the warm air and push the warm air upward. Anytime you have air rising upward, it's going to expand and cool and lose its ability to hold moisture, and this will give you a band of clouds and precipitation along a cold front. On weather maps, if you watch the weather on the news, you can see cold fronts marked by lines of blue teeth that point in the direction the cold air is moving. Along cold fronts, you typically have very intense local thunderstorms and rainstorms. So it might pour rain for a short time, but then quickly, usually within an hour or so, the front will have moved on. So a cold front is where the cold air pushes underneath the warm air, and you have high rainfall and usually intense thunderstorms. Now, the warm front has in common a couple of things with the cold front. One is that the warm air still goes up on top of the cold air, but in this case, the warm air is actually pushing the cold air out of the picture. So the warm air is winning, and that's how you can remember it. It's a warm front. The warm air pushes against the cold air, squeezing it out. Like imagine squeezing a watermelon seed between your fingers. It kind of squeezes out, right? And as the air pushes, it also rises up over the cold air. Rising air, again, loses its ability to hold moisture, and you tend to get clouds and rain. Along warm fronts, you typically have more mild, more mellow, more spread out rainstorms rather than really local intense thunderstorms. And if you're looking at the weather on the news, they mark warm fronts on maps with red half moons that point in the direction that the warm air is pushing the cold air. So that's cold fronts and warm fronts, major precipitation belts in many places on the earth.
Okay, so on our vocabulary words, we had high pressure, low pressure. We had fronts. You know what the front is? That's where they meet. Just like fighting on the front. That's actually, like he said, where they got the name of it from. And when it pushes and the warm air lifts That's where we get that lift word coming in. Okay. All right, so in your interactive notebook, you're going to have 2 pages that are going to have some descriptions of different fronts. Okay, so cold fronts occur when the colder air mass overtakes a warmer air mass. So here we go. Warm front or cold front moves in, this moves over. These are all things from your notebook. Warm fronts move slowly. That's the one that he just showed us. Okay. And a stationary front. A stationary front is when you have a cold front and a warm front and they just stay there and you get clear skies and some light rain, nothing too big. Okay. We like stationary fronts because that gives us nice weather. All right. So your assignment today, go right here. It says assignment. Okay. Open it up. And what you need to do is on here. So you have 3 things to do. Number 1, copy the 2 new slides into your notebook that are located in the 507 section on Google Classroom. So look right, oh, there they are. And the front cover is pink. Okay. I try and make them different colors so they're easier to find. Whoops, don't need that anymore. Okay, then you need to enter in your barometer data on your chart today. Now, there was a question that came up in one of the Zoom meetings. Is my barometer supposed to be changing a lot or even stay just the same? Well, think about it. What's our weather been for this last couple of days? If it's been the same, then we are not going to have a lot of change of pressure. The pressure changes come when we have a change in the weather. Okay, so if it's the same, then it's the same. Please also don't forget to go to the myweatherdata.com website and get the more technical reading as well. Okay, and then you're going to be doing putting in these definitions into your interactive notebook. Okay, there's a few that we need to catch up on. Now, your interactive notebook, when you are done, should look like mine. So I'm going to go through mine very quickly with you. Let's see. Anyway, okay. So your first one, that is not going to work. 2 seconds. Sorry. We'll put it back to fit. Okay, you should have your cover. You should have these vocabulary words filled out. And I can post a master list if you need one, no problem at all. You also should have a key points page. You should have your first model. You should have your scientific principles again for the next section. You should have your convection page, your second convection model, your third convection model that looks like mine, and then the 2 weather front pages. Okay. If you don't have these all, they are all in Google Classroom. You will need to scroll through and see what was put on there. Look for, I can't tell you the dates off the top of my head, but look for things like a new SIN slide. Okay. All right. Hope you guys have a great day. Any questions, come talk to me in the Zoom or send me an email. And I hope you guys have a great day. Bye-bye.